So what team are you guys?
Coding Cougars.
Where are you from?
Cupertino and San Jose.
Alright. So can you guys point out different things on your robot?
So one thing that's unique about our robot is our treads. We used to use skids, but it kept getting stuck over here in other missions, so we started using treads because they were more reliable and yeah.
And also, after we chose skids, we used to use the plastic treads, but then they didn't go over this, even though we never go over this in the program. So we changed it to rubber.
So another thing is the wall follower over here. Helps us see if our thing is going correctly and distances from the wall so it doesn't crash into it.
Okay, so where do you attach your different attachments?
So we have one basic attachment over here that always stays on during the challenges, and we add another attachment to the basic attachment here. So it's sort of like an add-on, and then there's one in the front over here that we added.
And this one, this lever thingy, it always stays on too. Same with this.
It's like a sort of arm.
Now can you guys point out your different sensors?
Yeah, we have a touch sensor here in the back. Once we press it, the next program starts. We put them in buy blocks, so the next buy block would start going. And it's a lot more efficient and it saves a lot of time.
Okay, so on the bottom here, we have the color sensor attached, and it helps us with our line following over there.
Can you just hold up your attachments? You can just describe them one by one.
So this one, it attaches onto here. These pieces are designed to block the food from sliding in and going under the shreds. And this one is used to push this part, this L-shaped part is used to push the food into the circle over here.
So this attachment is for the pig. It is to hold the pig and put it here. So basically we tuck it under the color sensor and this secures the sides of it. So then it drops it off here. And then this kind of pushes the lever over here to the end.
Which of your attachments require motor power to use?
This arm requires motor power. It's connected to a motor.
And we never take these two off.
Why did you choose this particular design for your chassis?
Because it's small and compact and it won't break if you drop it into a million pieces.
You guys can point out stuff on your robot.
And also, it's pretty steady because of the treads, and it doesn't skid as much.
We have things such as wall followers to help distance away from the wall so that it doesn't crash into them.
We also use a touch sensor in the back to make everything faster between programs.
Most teams don't use treads, so why did you pick tracks instead of wheels?
Well, we chose treads because the treads are more sturdy and they're good at turning.
And if you need to go on this thing, then with the skid it just gets stuck somewhere there.
And it's
The
more
back
treads.
ball.
And the treads are more reliable. They succeed in missions more than the skid did.
The only bad thing is that it's kind of small.
Where do you attach different things on your chassis?
We don't really attach many things.
Just two attachments.
Yeah.
We wanted to make it small and compact so we don't waste time and not barely any attachments.
So
Attach one down here right next to the front wheel. It blocks the front wheel and pushes the food onto
yeah,
there.
and then we also put this here so that we can push the pig into the farm area.
And also push this lever for you.
In terms of attachments, we have a minimal number just to increase efficiency. We have 2 attachments that perform multiple tasks.
So are you a rookie team?
Yes.
Okay. So what is your robot best at?
Shark Tank.
As in
As
programs?
As in general things on the board.
The
Shark Tank.
I think it's this.
No.
Shark
Maybe
Tank.
I think this whole program where the Shark Tank and the dog challenge.
Except
They both always work. It's only been a few times that it hasn't worked.
It's one of the lesser complex programs.
Did you ever redesign your robot?
Yeah.
Yeah.
So what did you do?
So after the qualifiers, we thought we didn't make it. So then we just played it, like took everything off. Then like on Sunday we were informed that we won the lottery and we were coming here.
So we had to rebuild it, and when we were doing that, a few things changed because we didn't have exact pieces. So a little bit changed, but even before we sometimes rebuilt it, we didn't rebuild the whole thing. We kind of had the same general idea, but we rebuilt like attachments or improved them to match the challenges.
Before the qualifier, we had a really basic robot, and as we did more challenges, we added things to our attachments and robots and made it more complex.
Okay. So how did you come up with the design for your chassis?
We just like we chose which missions to do, and then we just put attachments on that would work for the missions, and then that's what attachments we chose.
And we also made our attachments based on how easy it would be to put them on and take them off.
For your attachments, how have your attachments kind of changed over time?
A little bit.
For this one right here, we used to have like a stub in front that kept it pushed forward, but then later it kept pushing it out, so we took it off and added these two pieces so it would just slide into the circle
And
better.
this attachment didn't really change at all.
Or in your code, how do you ensure accuracy over some amount of distance?
Sometimes we have square ups over here, and in the first code we have wall followers. We have a wall follower so we know it's going straight.
And it also keeps its distance from the wall so it doesn't like start slanting and crash into the wall.
In general, too, we use degrees instead of rotations. We just find it more precise.
Do you line follow?
Yes, in that code, but it's still twitchy, so.
But does it, how accurate is it?
It's very accurate when it works right. We're still editing our code, so I'm not sure if it'll work if we show you guys, but it's accurate.
You can try running it.
I know, but the reason it doesn't work is because we designed it so the cow would be
Like
pushed
pushing.
in, but in reality it's supposed to be pulled out.
So we didn't know that till we came here, so that would make it more efficient.
Do you use a gyro for driving?
No.
What different kinds of sensors do you guys use?
Well, we use a touch sensor. It's in the back. It's more efficient, and when you press it, the next program starts.
And the color sensor.
We also use the color sensor. This is for our line following program. For example, in the line following, if it senses like a light value of 3, which is black, then it moves away from the line, and if it senses white, then it moves back in. So it does this crisscross motion as it's line following.
After you arrived at the tournament, which missions required tweaking?
Well, this one, yeah. That was,
This one and this one too.
No,
I think that one a
no,
little
that
bit.
one was fine. This and that, little.
The conservation and the line following needed the most tweaking.
Yeah.
When you are in different tables, do the missions perform differently?
Yes.
Slightly.
So,
And we always have to make sure to check the mat, because if it's placed slightly differently, then our whole program shifts and changes.
yeah, it's like the practice tables, it works like perfectly, but then the tournament tables, like a few things go wrong. So
This is one thing.
Perfectly back.
So how do you deal with fixing programs? when you-
for usually.
Oh, do you want to go?
Okay, so like when we were making programs, we started going back to it, and we played the program that we already had, even if it messed up, just to see where it was messing up. So we basically like went back and troubleshooted it. First, we changed like the degrees by a lot, and then if it was like too much, we started changing it by a little back and back.
After you went home from the qualifier, did some of the programs still work? After
All
you-
of them did.
Programs work, but for us, we actually didn't qualify at the very beginning. We actually won the lottery, so we completely like stopped all the programs. So
But it still
we had
did
to-
work.
Yeah.
Alright, so what is the best score you can possibly get?
140.
148.
148.
148.
It's 138.
148.
I'm pretty sure it's 148.
30, 45.
Okay, well, it's about 138,
Alright.
138.
What's your highest score here?
60
65,
something.
67, 64.
That's because this doesn't work and
65.
sometimes it doesn't work.
That always didn't work.
So are you all rookies?
Yeah.
So what were some surprising things you learned about the event? The things you think that you wouldn't have thought?
We
That
qualified.
had to be pulled out.
We had no idea.
Usually they're mostly technical things that we didn't expect.
Do you have experience in programming or building these
Well,
before
like
this?
kind of.
Yeah.
Like some of us went to some programming classes before, and we had a lot of Legos, so that's pretty much it.
How often do you guys meet generally?
Like for this or like generally?
Like generally,
But pretty often, we're family friends, so.
Maybe once or maybe
Twice a week?
No, once
Twice
a
a
week.
week?
Once a week.
Just like once.
Yeah,
2
once a
weeks.
week.
Especially when there's like a
Once a week.
special occasion, then we like have a
what,
party.
what about closer to the tournaments? Did you meet any like more often?
Yeah, we
every
used
day
to
of the
meet. We used to meet every
single
week,
day.
but then like as it got closer, we used to meet every day.
Yeah, and we stayed for longer so we could work out the.
So how did you guys get into FLL?
Our parents asked us if we wanted to do it.
I guess our parents found it online or something. I'm not sure how they found it, but then
So-
they asked us if we wanted to do it.
Actually, it was my idea to go to FLL, and I asked my mom, and then she told all the parents, and then the parents asked the kids, and then we all said yes.
Yes, that's pretty much how we knew about this. Sohan came to me one day and he was saying in his class there are a couple of students who are going for FLL and I can't get in their team, but I really would love to go and participate. And I'm like, okay, let's figure it out. And I reached out to a couple of my friends and all these kids said they want to try it out, see how it goes, and all of us got together and started a team. We basically didn't know anything when we started. We had to learn every single step of the way, and even the programming. Even to this day, I don't know about programming as much. I just guide them. Then say, hey, you might have done something wrong. Why don't you go back and tweak your program? That's pretty much what we do as coaches right now. Do the administrative work and coach them, guide them, and they did most of the work so far.
So in both of these, it's easy one.
It's good and not work.
It was all the way pushed back in.
So that was a mistake. Supposed to get
Oh, just built wrong.
Oh,